Oklahoma Bridges here, and I wanted to talk briefly about the feed length adjusting mechanism in Singer 15, 27, 28, 127, 128, 66, 99, and 201 sewing machines. Because I've had a comment or two about how to get increased stitch length, and the principle on all these machines is the same. And I've got here a Singer 15-90, and I'm using this machine because it's extremely easy to view all the moving parts on this machine because of the large cover on the front for the stitch regulator. I have the machine laying here on its side to make it easier to see what's going on and how this happens. If you've ever looked inside the pillar of one of these machines, you'll see a couple connecting rods. There's, of course, the main connecting rod, which drives the bobbin driver from the main shaft of the machine. And this right here is the main connecting rod. And then there's this link rod right here, which has a forked end at one end. And if we go to the underside of the machine, there's the bottom end of the main connecting rod. There's the bottom end of that forked link rod. Then we have a rocking shaft, which comes down here, and at this end has two arms which connect to the carrier, which holds the feed dogs. And it's this rocking shaft, as it moves back and forth, determines the length of throw of these arms, which determines the length of the stitch, because it determines how much the feed dogs move. This rocking shaft has a crank pin here, which receives the lower end of this link rod. And the link rod, just below the fork, has a stud on it with a die block. There's the stud down there. This right here is the die block. And this die block slides in this channel right here, which is machined into this piece, which is pivoted. And the casting for that channel is extended out and has the stitch regulating handle attached to it. Now I'm going to show you the operation. I have the stitch handle in the position where it's going to produce a stitch length of 0. If I rotate the hand wheel, you can see the link rod and the forked follower following the dwell cam there on the main shaft. And you can see it's just moving back and forth. At the other end, I must have bumped it a little bit because I'm getting just a little bit of motion there. You can see that that rocking shaft is not rocking at all. It's staying stationary. But this link rod is swinging back and forth as the opposite end follows the dwell cam. If I move the channel to where it's not at right angles anymore with respect to this link rod, but move it down, you saw the link rod move, and I think I can demonstrate this a little bit better if I move this to where the die block is at the extreme there, so it's further away from the center pivot of that channel. And when I move the channel back and forth, the die block follows the channel and forces the link rod to move up and down. So there's forward stitch. Now the rock shaft is rocking, and it's moving the feed dog carrier backwards and forwards. If I move the stitch regulator to the reverse position, we're getting that same motion, but with respect to the main shaft rotation, it's 180 degrees out of phase now, and we get a reverse stitch. The motion that controls the up and down movement of the stitch on all Singer machines using this method of stitch regulation comes off of the lower thread driving mechanism, which in this case there is this jack shaft down here with a cam on it, and there's a forked follower attached to a second rocking shaft that comes and has a roller and follower arrangement that catches the opposite end of the feed dog carrier. So you can quickly see now how the stitch length is derived and regulated by simply moving this channel back and forth. To increase the stitch length, we can increase the angle of the channel, and it does seem like you can make it go further this way than this way, although keep in mind it's with respect to the angle. It's not with respect to the angle of the machine, it's the angle of that channel with respect to the center line of the cam here and this center line here, and it's inclined in the machine because it goes from the middle here to the back edge down here. So the middle position is not a true right angle, it's offset slightly. If we could make this channel go down further, we could get an increased forward stitch. You can only do that to a certain point because you will eventually reach a point where the mechanism will jam up. You can also, to increase the stitch length, move this pin closer to the center line of this rocking shaft. Now, on several other machines, the stitch regulating handle looks very different. On the 201, it uses this exact same mechanism because this is copied off of the 201. The earlier 15s use a smaller handle that can only move about this much. The later 15s, the 15- models, the 1588 through 1591, use this arrangement that was copied after the 201, which was introduced a few years before the 15- models were introduced. But this basic mechanism was first introduced with the original 15 in 1879. The 27, 28, 127, 128, 66, and 99 use this same basic link rod with the forked end and channel, but there is a knob on the front of the machine that moves the channel back and forth. The principle is the same. If you could move the channel a little bit more than what you can presently move it, you'll get a longer stitch. If you can come up with sufficient space down here to move this crank pin closer to the center line of the rocking shaft, you can get a longer stitch. You will of course have to probably slot the throat plate out to accommodate the longer throw of the feed dogs, and you may have to check to see that you have enough room here for the longer throw because of the longer path that this rocking shaft is going to have. I hope this clarifies the operation of the stitch regulating mechanism on these machines and helps you with your possible modifications that you might want to undertake, or just helps you understand the general operation of the machine better. This is Oklahoma Bridges. Thank you for watching.